I'm Anil Kumar, and in this video, I'm going to discuss in details the technique of curve sketching. Let us sketch graph of the function f of x equals to x to the power of 4 minus 50x squared plus 6. To begin with, you should analyze the function itself. Now, the function you can see is a polynomial, right? Is degree 4. Leading coefficient is positive, right? So you can say that leading coefficient A4 is positive. Now what does that tell you? Now all this information tells you one thing, that the graph is continuous, there are no discontinuities, smooth curve, and most important, as x approaches positive or negative infinity, y approaches positive infinity, and that's the end behavior, right? So that's what you get from the analysis of the function itself. A polynomial of degree 4, that means domain is all real numbers, and the end behavior is as x approaches positive infinity, y approaches positive or negative infinity. Now let me use this lower half to sketch or to show what we have got from the analysis. So what we are saying here is that when x approaches positive infinity, y approaches positive infinity, and that's the kind of end behavior we're talking about, right? Okay. Now from here, this is basically a quadratic equation with x squared, so you can also find x and y intercepts. Y-intercept is simple. You can always substitute 0 for x, and once you do that, you get f of 0 as 6. That means y-intercept is 6, right? So along the y-axis, it will cut at 6. However, to find the x-intercept, you have to substitute f of x as 0, correct? So to find x-intercept, we can actually use the quadratic formula. So let me use the quadratic formula and calculate the value. We can say x squared is equal to minus of b, which is 50, plus or minus 50 square, you can decide minus 50 square, minus 4ac, 4 times 1 times 6, divided by 2a, right? 2 times 1 is 2. So this is x squared. So let's calculate this value. So within square root, we have, let's do square root part first. So within brackets is minus 50. We have to square this. Minus 4 times 6, 4 times 6. And that gives you 2 squared. Let's find decimal value of this. 49.76. So what we get here is 50 plus minus, 49.76, let us say, divided by 2. So that gives you two values for x squared. So one is very close to 0, right? 50 minus 40, that means 1 point something divided by 2. Very close to 0. So very close to 0. The other one is very close to 50, you can see, right? So approximately, let me add 50 to this and then divide by 2. So we get in decimal, one value is 49.87, right? And the other one, which is 50 minus this, let's do 50 minus 49.76 divided by 2. In decimals, 0.12, right? So these are the x square values. So x-intercept will be at x equals to plus minus square root of 49.87, which is plus minus, let's find square root of 49.87, 7.06, okay, so that gives me 7.06, and the other one is x equals to plus minus square root of 0.12, which is, okay, square root of 0.12, which is in decimals 0.35, we can say, right? 0.35. Anyway, plus minus. Okay, so we found that these are the x-intercepts. We found the y-intercept. Okay, now you'll also observe that f of minus x is actually equal to, when you substitute minus here, minus, I mean x to the power of 4 minus 50 minus x squared plus 6, it is same as x to the power of 4 minus 50x squared plus 6. So it is equals to f of x, and therefore we can say that the function is even, right? So the function is even. That means it is symmetric about the y-axis, correct? So we learned all this. Now, let's analyze the first and the second derivatives, and then find maximum minimum for the given function. So the first derivative for the function will be 4x cubed minus 50 times 200 x, and that is 0. This could be, let me take 4x common. In that case, you get x squared minus 25. So that gives you two zeros, right? Or let me write this as 4x times x plus 5 times x minus 5, right? So that is the first derivative. Now, you could analyze this first derivative and find maximum and minimum. So let's do it here. So let's say this is, we're trying to analyze first derivative. We got zeros at 0, plus and minus 5, right? So I'm not just writing these, showing these points where we have zeros. So the zeros are at x equals to 0, at x equals to minus 5, and x equals to plus 5. We're trying to analyze the first derivative f dash x. If you take a test point, which is, let's say, negative 6, in that case, this is negative, that is negative, and that is also negative. 3 negatives makes it negative. So this part of the graph will be negative, right? If I take a value which is slightly more than minus 5, let's say minus 4, minus 4 will make this and that negative. 2 negatives make positive, so this part will be positive. That means its function is increasing in this interval. Okay. Now, if you take a value which is in between 0 and 5, let's take 1, that will be negative, but these two will be positive, so 1 negative will make it negative, and then greater than 5 will make all 3 positive, so it'll be kind of like this. So that clearly gives you that we have a minimum at x equals to minimum at f of minus 5, and since it is an even function, that should be equal to the minimum at 5 also. We can just plug in 5 here and calculate this value, right? So let's do this. So what I'm trying to say is we'll do 5 to the power of 4 minus 50 times 5 square plus 6. Use the calculator. Okay. So we have 5 to the power of 4 minus 50 within brackets 5 square, okay, and plus 6 equals to minus 619. So we get a value which is minus 619. So that is the minimum value, and the maximum is at 0. So this is the maximum for us, and these two are minimums, correct? Since the function is decreasing and then increasing, and here it is increasing and then decreasing, so you understand the concept. So f of 0 gives you maximum, and that is equal to 6, correct? The y-intercept. Okay, so we have analyzed the first derivative. That gives us maximum minimum, right? So this part gives us max min. Also intervals of increasing and decreasing. Now let's find the second derivative. Second derivative for this function will be 12x squared minus 100. Right. Now clearly this has critical points rather than numbers. At x equals 2, we can find those numbers here. So that gives you x equals to square root of 100 divided by 12. Is it okay? 100 divided by 12. The function is even, you know, plus and minus. Okay. So let's find this value. Square root of 100 divided by 12 equals to, in decimals, 2.88. So we have plus minus 2.88. Now let's analyze the second derivative. So what we have here is 2.88 plus and 2.88 minus. These are the two critical numbers for the second derivative. Okay. So if you take a test point, let's say 0, in between, if I take a test point 0 here, then this will be negative, right? So we get negative. If I take a test point on either side, then that value is higher than 100, so we get positive here. So that gives you the shape of the curve. So during this part where it is positive, the shape has to be concave up, negative means concave down, and positive means concave up, correct? So that becomes the shape of the graph, and clearly we have 2 points of inflections where the concavity changes, and these are at 2.88. So let's also find the value of the function at 2.88. Plus and minus will give you the same value. So let's substitute 2.88 here. So we get 2.88 to the power of 4. Okay, minus 50 times 2.88 square plus 6 equals to minus 339.92. Okay, so minus 340 approximately. Minus 340 I'm writing. Okay. Now that's the value. And this value is same for both plus and minus 2.88. And that you get from the symmetry of this function, since we know this is even symmetry. Is it okay? Okay. Now based on all this, we can actually sketch the graph. So what we figured out is that the minimum is at minus 5 and maximum at 0. So let me just draw some points here. I'm just drawing a line. These are for minus 5 and plus 5, and then 2.88. So I'm making a very rough sketch here. Okay. Now since this value 340 negative and also 617 negative, these are very high negative values. With respect to the positive value of plus 6, right, which is very close. So what I will do here is kind of break my scale a bit, right? And let's say this is around 600. So we have two minimums, one at minus 5. So let's say this is minus 5, that is plus 5. So we have minimum, let's say this is the minimum here. From symmetry, I'm drawing a minimum here. Now we have a maximum, which is at 6. So that is the maximum at 6. So we'll say let this be the maximum. Okay, so I'm just breaking the scale a bit. So I'm saying this point minimum here is at minimum is at minus 617. Okay, and then we have point of inflection, which is for minus 2.88 approximately, right? So this is 2.88 plus. So point of inflection is where the concavity changes. So it is like concave up and then down. So that is the point of inflection, right? So considering that, let me sketch this part here. So we have kind of a point of inflection here around this line, and then it turns back to this, right? So that's how the graph is, and along this line, and then it turns back to this, and then goes kind of up, right? And then goes up kind of like this. So that becomes the graph of this 4-degree quartic polynomial. You get my point, right? And we also found that these intercepts, the x-intercepts for us, we found these points also actually. We can label them. X-intercepts for us are minus 7.06. Let me write minus 7.06. And from symmetry, 7.06 here. The other one is very close to 0, which came out to be 0.35. So think this is like this to be 0.35 minus and this to be 0.35 plus. Is it okay? So those are your x-intercepts, correct? So that is how you can actually sketch the graph. So the critical points we found were the maximum value, the minimum values, which are plotted, point of inflections, right? There are two of them, correct? The x and y intercepts. So that is your y-intercept, and the x-intercepts are right there, this one and that one, correct? So we analyze the first derivative to find the minimum, maximum, minimum values, second derivative for point of inflection. Nature of the graph is from the equation itself, and so that is how you would actually sketch a very accurate graph for a function, especially a polynomial in this case. I hope that helps, right? So this value we can label as 6 as your local maximum and also the y-intercept. So let me summarize the steps which you have taken. Whenever you are given a function like this, any function, first analyze the function itself, what kind of function it is. Polynomial will be a continuous graph without any breaks, that is, and we kind of can work out the end behavior and do the needful as we did. If it is a rational function, we have to look for asymptotes, right? Vertical, horizontal, and holes. And we need to analyze the graph close to asymptotes. That's important for a rational function. So similarly for other kinds of functions, there may be some special things required. Now for polynomials, important things are to find x and y intercepts, analyze the first derivative for maximum, minimum, local maximum, minimum, and second derivative for point of inflection. I hope with that the graph comes out very well. I'm Anil Kumar. Thanks for watching the video. Feel free to share your comments and my videos. Thank you and all the best.